All right, Mike Camponovo. I'm the GIS Outreach Coordinator for the Geography Department here at UT. We want to help you be successful spreading the good news about geography all across the state or wherever it is that you are. So how many of you all have ever tried to explain to a layperson what it is that you do in the geospatial field? That can be a challenge. So when I explain what we do, a lot of times instead of talking specifically about what GIS is or trying to give a definition, I like to talk about examples of how we use it. We have our folks in the communications department put together this pretty slick graphic on different industries and careers that use geospatial technology. I have a stack of those in the back on the table next to where the Mapillary stuff was. If you'd like to take one of these with you, share it with a teacher, hang it up in your work so you can tell your coworkers what it is that you do all day, please take one of these with you. If you'd like a PDF copy, just let me know and I'll send you a PDF and we can print as many of them as you want. But we just love to get more people out there aware of what it is that we do. So a couple other things. One way that you can help us with this process is, are you all familiar with the GeoMentor program? I'm seeing a few people nodding heads. All right, so AAG and Esri have actually partnered up on this. And the plan is to get people who are geospatial professionals out in front of K-12 community to share with them what it is that we do and help bring up this next generation of geographers. So what's really slick about this is it takes about 5 minutes for you to sign up to be a GeoMentor. And let me just sort of show you here in Tennessee what we're looking at. So every one of these little red schoolhouses in Tennessee is a school that has an ArcGIS Online org account at their school. So I know not everyone in here is an ArcGIS person, but that's a pretty good distribution of schools around the state that are interested in geospatial technology. The other thing that's pretty cool about this, let's see here. Okay, so here's our map of people in Tennessee who've already volunteered to be GeoMentors. I'd like to see a lot more dots on this map, and you do not have to be an Esri person to do this. Some things that you can do if you're trying to help educators and students learn more about this. GIS Day will be coming up in November. If you've got maybe a spouse, a kid, a friend, a neighbor, someone you go to church or Puritan or Lions Club, whatever with, and they work in the K-12 space, talk to them and find out if you can come in and be a guest speaker on GIS Day in the fall. You can email the folks at the GIS Day website. It's Joseph Kursky with Esri. They'll send you a box of goodies you can give out to the kids. Tell them a little bit about what you do. It's real simple. It'll take about an hour of your day probably to go out and talk to some folks. Teachers across the state are looking for help with projects and data. A lot of you all are very good at finding data. A lot of you, if you're working in local or state government, federal government, even the private sector, you've got project ideas that students can work on. And show them some of these tools, show them how they can use them. Again, I know this isn't an Esri shop, but all those schools can get a free ArcGIS Online org account. So they can run collector, survey 123, the whole bit. So just so you all know, that's all out there. We'd love for you to think about signing up to be a GeoMentor. It takes about 5 minutes of your time. And I did want to share with you some resources to be like, Mike, this sounds cool, but I don't even know where to start. I work with Kurt Gudafish with the Tennessee Geographic Alliance, and Kurt and I have put together this open data portal to let people know about some resources that are available. So it's just this data link. Okay. In Tennessee right now, there's been a big push for the next-gen science standards to be adopted. So science teachers across the state are scrambling to find content that oftentimes they haven't taught before. This is an awesome opportunity to show them how we can use geospatial technology and incorporate it into their curriculum. So there's a whole section up here on story maps. I don't know what the open source equivalent of a story map is, but I'd love to know what those are so I can share those as well.
Mapstory.org.
All right, I'll find out about those and we'll add some of those. You know, there's like a great one about Kilauea up here already. So that's been in the news a lot, so science teachers are loving that. There's these things called geo-inquiries. They take about 15 minutes worth of time. You don't have to have any sort of software to download. You don't have to have any accounts. It's just you go find a 1.5 page PDF lesson plan, and there's an interactive map that goes with it, and they cover everything from elementary school topics to AP topics. So all you really have to do is help the teacher facilitate that in the classroom and help them figure out how to use a web map, which most of us can handle. There's a whole section in here, Teach with GIS. Again, that one's ArcGIS heavy. But what I thought you all might be interested in is we've been putting together data, apps, maps related to science topics that we can share with teachers. And what we've been trying to do is, when possible, find local data, state data, national data, and global data. So when we're teaching kids about these topics, we can teach about it at multiple scales, because that's important when we're talking about geography. So I know there were some folks interested in wildfires. So we got wildfire point data for every wildfire in the U.S. that we can get data for. We've got polygons for every wildfire in Tennessee from 1980 to 2016, I think. We got tons of earthquake data in here. And for any one of these, you can just click on these, open them up. You can filter the data out by whatever it is that you want. So if you want to get just the spatial data sets, you can grab those. And if you want to do this in the open spatial world, so here's global earthquake data, a year of global earthquake data, you can actually download that as spreadsheets, KML shape files, whatever it is you want to get. But all the data is up here, spatial data, as well as their pre-built maps, pre-built apps. There's even tabular data, things like that in here. So any of those stuff you want to play around with is all here. If you think of something that you want to teach kids about or share with a teacher, 4-H, any sort of educational thing, just let us know. We'll be happy to find some data and add it up there for you. True North, who's here from True North? Oh man, you guys are making me really happy right now. So there's a teacher in Murfreesboro, Clay Burns. He's teaching the brand new Intro to GIS course for the high school class. It's a career and technical education course. He's doing that for the second year in a row. He was our first teacher in the state to teach it. Clay was posting information about his class, and the True North folks posted online, since they're both based out of Murfreesboro, where Central Magnet Academy is, and said, anyone that signs up for Clay's class, we'll select one of those students to be an intern, a paid intern with us, as a result of taking the class. So there are lots of different ways you can support the K-12 geospatial community in Tennessee. So we'd love any support with that. If you've got ideas, suggestions, you have questions, please just drop me a note and let me know. So we'll skip all this stuff for now. I do want to let you know that there are a lot of things that we're doing across the state. Kurt and I travel around quite a bit, so we'd love to help you out personally with these projects. And maybe you know a local teacher, you don't know how to get started, but maybe Kurt and I can come out and work with you. So some of the things that we're doing are, I can't believe I forgot to bring this because it weighs 400 pounds with all the junk in it. But Oliver Kralos out of UC Davis has put together this great open source AR sandbox. And this thing is just a really cool interactive sandbox. It's a great way to teach physical geography, watersheds, topography, map reading, and you can even teach about remote sensing, because it's actually using Microsoft Connect to measure the distance down to the sand. So you can talk about infrared and how it's measuring that distance. That's a thing we've set up, unfortunately, 34 times this year, I think, so far. So we bring that out. We also have a sim table that we can bring out. And if you've not seen the sim table before, it's a very similar idea, but it's primarily used by the emergency management community. So there's some science standards related to natural disasters. We can simulate flooding, wildfires, a bunch of different natural disasters using real geospatial data loaded in. It uses cellular automata for those, but that means something too. I've never used it, so I don't know. But anyway, we can process and run a bunch of cool models and simulations, so we can see what happens if you change fuel density, what happens if you change wind speed, what happens if you change fuel type. So if you're talking about what's going to happen due to climate change and things like that, those are all simulations we can run with students on that as well. So we'd love to bring these things out to schools and get more kids excited about geography and wanting to be engaged with us. So from an outreach standpoint, that's it. So just email me if you got anything you need to get in touch with me about. I got a stack of business cards, so I'll leave those here if you need them. We talked about the open data portal, sandbox, table. Oh, someone mentioned this earlier. I love this little tool. Have y'all seen Map Shaper before? I see a few folks nodding your heads. I used to do a lot in the open source world, so we would work some in Leaflet, and I would need to do things like reduce the geometry to make things load faster in Leaflet. This is just a super fun tool, so let's grab some Tennessee counties real quick. Hopefully that's right there. Select. Oh gosh, what did I put?
Oh, you need to select the record import.
Thank you. Okay, thank you, import. Because you mentioned this Douglas guy here. So anyway, what's slick about this is if you want to see if you reduce the geometry, what sort of impact that has on your data and how that's going to look, you can really start to play around here and figure out how far you can simplify things to reduce your file size so things will load faster, things like Leaflet, but still keep the geometry that's really important. So we found that you really reducing to about 90% and keep a lot of the geometry, especially at this scale. Anyway, Map Shaper is just a fun little tool. The other one that I teach my students how to use all the time is Tabular. They're always trying to pull data, tabular data, out of CSVs. Out of PDFs. And PDFs are notoriously hard to get those tables out of. This is a great tool. You just go to tabular.technology, download it and run it. You just open the PDF and highlight the table that you want to pull out. It'll extract all that out as a CSV for you, so then you can do a lot of fun things with that once you have it as a CSV. But it's just a pretty slick little tool. I just thought since I was here I'd tell you all about that one. All right, so Mapillary. So basically what we ran into is this time last year I met Jonathan Rigsby here. Jonathan works for Blount County. And Jonathan had found this cool tool to play with and work with. And it's a way to collect your own open source street view imagery. So on UT's campus, our street view imagery is about 3 years old the last time I checked. So a bunch of buildings, if you hadn't noticed, a bunch of buildings have been torn down and been replaced. So a lot of that stuff is still up there. Plus a lot of our bike paths, walking paths, that sort of stuff hasn't been collected. So what we've been playing with is this thing called Mapillary. And basically the way that it works is you can take your smartphone, there's an open source app on your smartphone, you can walk around and collect your own data, or you can do what we did, which is basically do a Kickstarter campaign, and you can raise some money so that you can buy either 360 cameras or action cameras. So I got a lot of stuff. Anyway, so we bought 4 of these little Sony action cameras. We have a kit right now. We strap these to the top of my car. We drive around, so we collect 360-degree imagery on our own with these. And I've got some parts and pieces on order, so we're going to start figuring out how to strap them to bicycles and backpacks, so that like if you want to hike the Cumberland Trail and collect street view data of the Cumberland Trail, you can do that. Or greenways, because a lot of us have living communities that have greenways now. But just to kind of show you a little bit about what you can do with this, because it's a lot of fun. So, and as you all know, anything open source, sometimes it's hit or miss on coverage where you are, and the quality of what you collect can sometimes be a little lacking. I'm just going to filter this out to my data. And let's search here for So there's tons more data. I've just filtered it out because it gets overwhelming. And so this is just me walking around with my phone holding it out in front of me. And it's just using the GPS, accelerometer, etc. in your phone. And then as I'm walking, it's stitching the images together. So it's creating a point cloud, so structure from motion, for those of you that work in the point cloud world. So what's really slick about this is if you wanted to do something like a sign inventory, we didn't want to have to drive around and GPS each individual sign, each of those pixels, as long as the same object has been in at least 3 different photographs, you can triangulate that position so each one of those is geo-referenced. And then, because what's fun about this, if we don't do something with convoluted neural networks and all that stuff that I don't know anything about, but they're actually training their software to pick things out of the imagery. So in this case, it knows that's vegetation, it knows that's a road, it knows, oh, it thinks that's a person, so it's not perfect. There's our sidewalks, crosswalks, terrain. Yeah, that's not a person. But anyway, and what's really slick is you can use all this, it ties directly into OpenStreetMap. So if you wanted to collect data, imagery, you can take all these tools, tie them into OSM, and you can actually start to do all your digitizing based off of this. So this is just a sample of imagery taken from my smartphone. Yes?
I have a question. On geoethics and all that, now when you record people, right, is that like a caveat to
Let me see if I can zoom in right here.
like face recognition software?
So their algorithm, it's blurry where you all are looking at it, but it's actually blurred out that person's face. So it blurs out faces and it blurs out license plates.
Got it.
It's not perfect, and you can go in, and if it misses a face or it misses a license plate, you can go through and add that blur yourself if you need to.
Thank you.
Yep.
Silly question of the day, probably.
Sure.
If this uses 3 photographs or more, could you use it to measure like the width of a sign or anything?
I'm sure you could if there was a measure tool built in. But I don't know if there is a measure tool built in. Let me just give you a different example.
Historical history. Do that. We need to know the area. So this might not be.
So, and just so you all know, what we did was we strapped all these to the top of my truck. So there's one camera that points straight back, and then my truck is huge compared to these cameras, but there's one that points mostly forward, and then one on each side. And it turns out that if you have these ridiculously long bars on your truck for hauling canoes and kayaks and stuff, that you kind of actually need to move all your cameras out to the end here so you can still point them straight out. But once you've done that, it actually does a great job of collecting that imagery. I mean, it's not Google, but there's $2,000 worth of equipment in this bag, and I can collect all my own Street View imagery wherever I want to go. And I don't have to do it on Google or here or Apple Schedule. We can just do it whenever we want to. The only thing you got to keep in mind is when you set the 4 cameras up, what you actually do is you take the compass angle that each camera faces, and when you upload the data, you set that camera angle, and then it just assumes that each picture that is taken in sequence. So as long as you set those in the right order, then it's doing a pretty good job. Actually, you can see there, it thinks that's a license plate, so it's blurred out the Ford logo and that sort of thing.
Just a crazy question.
Yeah.
Have you extracted point clouds from the optical?
I have not. That data is available, but I wouldn't know what to do with it if I had it.
Well,
So,
you could in theory,
Mhm.
right?
Yep.
Surface.
Yeah. They have some cool videos on their website where they actually show the point clouds and how they're extracting all the features from it.
Now, is there any way just to play a video with the map feeding along with it and being able to manipulate it, or is it
I don't
more
know
of
if
the
there's
street
a,
view?
I think it's more of a street view thing. Now, I do know that they have, if you have multiple pictures from the same location, you can do a time slider like Google does, but not as far as like just a video going down.
Oh,
the
so
street.
these are stills, this is not a video, there's whole stills shot at every certain,
In this case, one picture every second,
Gotcha.
times
Okay.
4 cameras. It does not take long to get about 10,000 pictures. there's a web uploader tool. And for those of you that actually know how to use Python, there's a script to do this, but then you don't actually get to watch the really fun part where it loads all the pictures. So otherwise, you just take all your pictures, you drag and drop them into the web uploader, and I am such a nerd, but this is so much fun. Where you'll actually start to see each one of these points where there's a picture, and then the angle is the angle that the camera was facing. So then you can actually see my whole path as I drove around to collect all the images. And about 40 minutes worth of driving with 4 cameras gives us about 10,000 pictures. And then once you're in those pictures, you can zoom in and out. I know we're not supposed to talk about ArcGIS Online, but it ties into ArcGIS Online and ArcGIS Pro, so you can actually do editing of your feature classes in your desktop environment using this data. Plus, you can actually, because the software is extracting out things like the stop signs and all that sort of stuff, then it's actually will show up as a feature class in your GIS while you're working. But anyway, it's just a fun tool. We haven't had this stuff very long, so we're still sort of figuring out what all we can do with it. And we haven't collected a ton of data with it yet, so anyway, we're just looking for ideas and coming up with goofy things to do.
I said it'll extract out the street signs. How does it do that? I mean, what is the end result when you extract that out?
So let me get back out here. So basically what it will do is, let's see if I can get this to do this really. Okay, so there's a pedestrian crossing sign that it's picked out right here. And if we click on that, then it actually brings up the picture that we took driving around, and it sees this in multiple pictures, and it uses, again, I don't know anything about AI, but it's using that to identify that, categorize it, and then it finds the coordinates for that. So here's, see if that's actually a railroad crossing. So yeah, so there's the railroad crossing sign from 3 different pictures.
Then you could export the coordinates for any of those.
Yeah,
locations.
yeah. Like I said, they wanted to tie into OSM, so that's all completely free. The integration with ArcGIS Online is a service that they sell, but integrating it into OSM is completely free. Anyway, it's just a fun toy. We're trying to convince some folks just to let us strap cameras to the tops of like their county or local vehicles and just driving around and collect all their own imagery and see what we can do with it. Otherwise, yeah, I think that's it. Cool. All right. Yes.
Are you familiar with the Geo for All initiative?
Nope.
That's an open source geospatial education initiative that's international in scope. You can just do a quick Google for Geo. And I think it's, yeah, there you go.
What's it called?
Geo for All.
Okay.
And if you go to, you see the community one, at the drop down up there, the upper right, I think the community should get you to members.
Okay. So this is sort of like that Geo Mentor.
Well, it's a little bit different. It's institutions that have joined, and let's see. Now I'm not seeing it. There's usually a map up there that tells you, has it's a web map showing the locations internationally of all the members.
Okay. Well, we'll dig around on that and see what else is available there.
There's training documents and just different resources for folks that are interested in doing training with open source geospatial software.
Cool. One thing to keep in mind, if you want to go work with schools, you're never going to get anything downloaded on their Chromebooks because the OIT folks probably won't let that happen. So anything you can do web-based makes your life a lot easier when you're working in the K-12 space.
Yeah.
The most important thing about GIS Day is the day after, which is
Post-GISA.
Yeah.
Yes, I think.
That's right.
No, not beer day.
GIS joke for the day?
Yeah, that was good. Really hit on that one.
How do GIS folks find spouses?
No,
They date them.
that's bad.
Oh, that is bad. Shameless plug, FinJig regional meetings are all coming up this fall. So we've got one coming up in Kingsport in September, one in Middle Tennessee and one in West Tennessee. And then there's the big magic conference for the rest of the folks in West Tennessee. So lots more opportunities to go out there and spread the good news. That's it. I'm done.
Thanks for coming out. Meeting number 2 in the books.